chapter 18, we want to look at probability models, which is a little different than just looking at probability as an understanding of chance and long-term behavior. So let's start with a case study. So looking at Super Bowl odds or probabilities of winning, you can find information pretty much immediately after one team wins the Super Bowl as to who the next winner might be. So this table here is from 2015, looking at the probability of different teams winning the Super Bowl for that season. And you can see that each of these teams was given a particular probability, and the Green Bay Packers had the highest probability, and then it kept going through the Jacksonville Jaguars. So how would we interpret these probabilities? Well, ultimately, these are going to have to be personal probabilities because they aren't based on any understanding of long-term behavior. We also should recognize that these particular probabilities were from September at the beginning of the season for football, and so things would probably change over the season based on how the teams are doing, trades, injuries, all sorts of factors could affect that. So what we're going to be doing in Chapter 8 is we're going to look at how probabilities behave, the rules that they have to follow in order to make sense. So let's start with this idea of a probability model, and we're looking at the probability of any marital status for the proportion of women aged 24 to 29. So you have four possibilities here. You can be never married, married, widowed, or divorced. So we look at these probabilities and we see that for any given woman aged 25 to 29, she has a 0.478 probability of having never been married. So about 47.8% of this group would have never been married. So you can think of this table as if you were to randomly pick a woman from the population of age 25 to 29, these probabilities are telling us the likelihood of this particular woman being in any of these categories. So if we wanted to find the probability of not being currently married, we could calculate that from this information. So who are the people who are not married? Well, those are the people who have never been married, are widowed, or divorced. And to find that probability, we'll simply add those three categories together and find the probability is 0.524. Now, this model does more than just assign a probability to each individual outcome. It also helps us find the probability of any collection of outcomes, and we can get that by adding these individual outcome probabilities together. So when we talk about a probability model for a random phenomenon, it's describing all of the possible outcomes, and it says how to assign probabilities to any collection of outcomes. Sometimes we'll call those collections of outcomes an event. You have a few rules that you need to understand for probability. Probabilities have to be numbers between 0 and 1. So any proportion, by definition, is going to be between 0 and 1, and so these probabilities are going to be between 0 and 1. So an event with a probability of 0 means that it never occurs. An event of probability 1 means that it occurs every single trial. And then 0.5, like we talked in Chapter 17, this means it occurs in about half of the trials in the long run. Now, we're going to add a little bit for Chapter 18. If we consider all possible outcomes together, they must have a probability of 1, because something has to occur in every single trial, so that means that something happens. That probability means that it has to add up to 1. With that, we can then talk about the probability that an event does not occur, and that would be 1 minus the probability that the event does occur. So let's say that an event occurs in 70% of trials, then it would fail to occur in 30%. It either does or doesn't. And so the probability that an event occurs and the probability that it does not occur will have to add up to 100% or to 1. And then the last rule here is if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So for example, if one event occurs in 40% of all trials, the other event in 25% of all trials, then together that would be 65% of trials. So let's apply those rules to the example we looked at a moment ago. We're looking at the marital status, and we could find the sum of all of these different statuses. They add up to 1. So you have to have one of those 4 groups. So that works for rules A and B. But now let's think about this next question. If we wanted the probability of being not married, then that would be 1 minus the probability of married. You either are not married or married. So we could do 1 minus 0.476, and we would get the same value that we got from adding the 3 categories that included all of the not married people. So Rule D is helping us see that we could also find the probability that a woman is not married by doing what we did in the previous example by adding the 3 distinct ways of not being married.